Hey everyone, and welcome to part 2 of our algorithms for adding and subtracting video. Now, in this video, I'm going to be talking about subtracting and the different strategies and procedures we take for our algorithm that we established in the last video when we talk about subtracting numbers. Now, with the general subtraction algorithm, it's going to work in a very similar way to the adding one, at least in terms of the layout. So if I take, for example, 74 and I minus 15 for that, starting with an easier example, only 2 digits here. Once again, I'm going to lay this out. I'm going to kind of stack this vertically here. And I'm going to show you how we can approach a question like this. So we're doing it in the same way. We're going to split up or by drawing it vertically like this, we're splitting up our ones and my tens column. And now, just instead of adding, we just want to subtract instead. Now, you may notice if you try to go about this, you may see that in this column here, I'm subtracting 5 from 4. That's a bit odd because if I look at my number line, so for example, my 4, 3, 2, 1, 0. Remember we said when we subtract, we're kind of going to the left direction of our number line here. But I'm subtracting a bigger number from a smaller number. So if I wanted to go 5 less than 4, I'd go 1, 2, 3, 4. And then I end up somewhere on this side of the 0, the left of the 0. Now, for the time being, this is kind of uncharted territory. We haven't ventured anywhere to the left of the 0 just yet. We will in a later series when we talk about negative numbers, but we run into a bit of a problem here. So you may remember from the addition algorithm, we talked about when our digits change. So for example, when we added two numbers and they got bigger, it made a 2-digit number, we carried over a 1 to the other column. We're sort of doing something similar here, but the way we're going to approach it is slightly different for subtracting. So to get a number here that's non-negative, I want to do something with this tens column, right? And what I do here, I can't minus 5 from 4 just yet, but what if, for example, I borrowed a 10 from my column here? Because I can do, if I added 10 to the 4, I can do 14 minus 5, and that'll give me a regular number. So all I'm going to do here, I have 70 up here, right? This 7 represents a 7 in the tens column. So I have 70 there. Now, what I can do is I can borrow a 1 from this 7 in the tens column and bring it over to my left column. So my 4 is going to become a 14. Now, if I've taken away 10 or borrowed 10 from this 7 or this 70 to get 14, this 70 is going to become 60. So, in essence, it's kind of happening in a reverse way to addition. Remember in addition, we always carried the ones over to the right-hand side? We're carrying ones over still here, but we're going to the left. We're borrowing from the right and going to the left because we can't subtract 5 from 4 just yet. We don't really know how to do that. But if we borrow a 10 from my column on the left, I can make 14 minus 5, which is a far easier thing to do. Now, if I do this, I'm going to get 14 minus 5, I get 9 here. And instead of now minusing 1 from 7, because I've borrowed a 10 from the 70, I'm minusing 1 from 6 up here. And what happens when I do this is I get 1 from 6, I get 59. Now, some of you may be looking at this and you may be a little bit hesitant. You're thinking, what's this guy talking about? We're borrowing these ones now and are doing this stuff. Does this actually work? Now, let's just check this on a number line. Now, I'm going to draw a really big number line from here to here. And I'm going to go from 74 all the way down to 59. So I'm going to do 60, 61, 62, 63. This is going to be a bit tedious, but I just want to prove to you guys that it works in the same way. 66, 67, 68, 69, 70, 71, 72, 73, 74. Let me just double check I've got all my numbers. Yeah, cool, we're good. Now, in the same way, if I want to subtract from my, if I want to subtract along my number line, I'm going from 74 and I'm going 15 places to the left. I'm subtracting 15 here. So in doing that, I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I've minus 15 from 74. So this is just to show you that it does work. But like I said in the previous video, the reason we have these algorithms here and these ideas and procedures is so we don't have to do all of this thing down the bottom here. It takes too much time writing out the number line, putting in all the numbers. And now we're only working with numbers in the tens. Imagine if we were doing this for hundreds. It's just not feasible to draw this entire number line thing at the bottom. So this is how we would subtract numbers using our algorithm. We're talking about this idea of, well, I can't take 5 away from 4 just yet. I haven't been shown how to do that. But I can borrow a 10 from 70, and that gives me 14 minus 5. So, and what I adjust here, I have to account for on my column on the left-hand side. So my 70 goes down to 60 because I've borrowed 10. I've taken away 10 from here and put it up here. So let's try one more question. And I'm going to do a bigger number here and show you how we could work through how this algorithm will work for bigger numbers. Now, I'm going to pick a 4-digit number. So don't get too concerned. This is just to show you how this works on a larger scale with a bigger kind of number here. So what I'm going to do in my example 2 is I'm going to do 3,240 minus 2,721. Now, 4-digit number, really big number. But once I have this kind of system, this procedure to do this, I find that it makes the question a lot easier. So once again, I've shown this vertically to separate my ones from my tens, from my hundreds to my thousands. So I'm dealing with each of these columns individually. Now, you should see here, I have 0 minus 1. Now, once again, I'm minusing a bigger number from a smaller number. So I can't really do this. What I want to do is I want to borrow a 10 from my tens column and put that up here. Put that up here. And if I've borrowed 10 from 40, my 40 becomes 30. I've taken away 10 from my 40. So my column to the right, my tens column, is going to change because I've lended a 10 to the ones column from my tens. So now I get 10 minus 1. That gives me 9. And now in my tens column, I'm subtracting 2 from 3 or subtracting 20 from 30. Now, in this case, my number on the bottom, sorry about this, guys. I have this here. My number on the bottom is smaller than my number on the top. I'm subtracting 2 from 3 or 20 from 30, and I get left with 10. Or 3 minus 2 in this column gives me 1 in this column. Okay, so far so good. Let's move on to the next column. And here, I'm going to, let's just color code this so we can really get a feel for how all of these columns are different. Now, I'm working with my hundreds here. I'm minusing, once again, a bigger number from a smaller number. So I'm minusing 7 from 2 or 700 from 200. I'm not going to be able to do this without borrowing something from my thousands column. So this 3 is going to become a 2. And I'm carrying the 1, you can see once again, but just going in a different direction. So I wind up with 12 minus 7, or because I've lended 1,000, 1,200 minus 700. And that gives me 500 because I'm just minusing. We have zeros here and here. So I'm just minusing these values, which correspond to these ones up here. So when I do 12 minus 7, or 1,200, 1,200 minus 700, I get 500. So I get a 5 in my hundreds column. 500. So I'm here at my last step in working in my thousands column. Let's highlight this one too. I'm minusing 2,000 because I've borrowed 1,000 from the 3 here. I'm minusing 2,000 from 2,000, or 2 from 2, just in the thousands column. What do I get when I subtract a number from itself? Well, I'm going to get 0. I have 2,000 and I'm taking 2,000 away. That's always going to give me 0. Now, the effect of this 0 just means that there is nothing in my thousands column. I have no thousands. All I have is my 519. That is my final answer. So my algorithm works for both addition and subtraction. And to do this and to do as big of a number subtraction or addition that we want, we can just follow this same procedure. Once again, we're looking at the patterns we saw coming up in addition and subtraction, and we're applying this to a bigger scale. This is what maths teaches us, guys. So we've now worked through 2 subtractions, one with 2 digits to give us the idea for how to work through this, and we've applied what we learned to even bigger numbers, to 4-digit numbers, working in these thousands. And we can work in the tens of thousands, the 100,000s, even the millions with this algorithm, with these procedures that we've come up with for adding and subtracting. Thanks so much for joining me, guys. I'll see you next time.